Today in the workshop we'll be building a remote-controlled robot car using the ESP32-CAM module. I'll show you the steps for building this car on a simple base or with your own unique design. We're on the move today, so welcome to the workshop. Well, hello and welcome to the workshop, and today we are going to be building, this. This is a robot car based around the ESP32-CAM module. Now, most of you are probably familiar with the ESP32 and the ESP32-CAM. If you're not, I've done a couple of videos on these devices. But basically, the ESP32-CAM module is an incredible little module that has a video camera. It can do Wi-Fi, it can do Bluetooth. It has a very powerful microcontroller, and it's got a very low price, about $9 US. I've coupled that with a few other components that are also very inexpensive to make this little robot car. And this little robot car takes advantage of the Wi-Fi capabilities of the ESP32, so we can use a remote interface with a phone, a tablet, or a computer. This device creates its own Wi-Fi access point, so you don't need to be in an area with Wi-Fi to drive the car. You can take it outside if you want to, and it is a lot of fun. And so let's take a look at the features of this car, the components, and then I'll show you how you can build this, either the way that I built it or with your own unique style. Our robot car will be based upon the popular ESP32-CAM module. The car will create its own Wi-Fi access point, so you won't need to have Wi-Fi and you can use it anywhere you want. You can use a phone, computer, or tablet to remote control the car using Wi-Fi and a web-based interface. The remote control provides for video streaming and has controls for video quality and video size. You can also control the video light on the car to illuminate the area that you're looking at. The remote control also has a speed control for the car. Let's take a better look at our simple remote. At the top of the screen, you'll see a spot for the video display. This is where the streaming video will be displayed. Below that is a button to start or stop the video stream. Note that when you first start the remote, the video stream will be stopped and you'll have to start it manually. We also have 4 buttons to control the direction of the car. You'll notice there is not a stop button, although there is provision in code for making this. This is because the car only moves when the button is pressed and will stop when it is released. There are also 2 controls to control the light on the ESP32-CAM module, one to turn it on and one to turn it off. 3 slider controls round off our interface. There's a control for the speed of the car, one for the quality of the video, and a third one for the video size. The main components of our car are, of course, the ESP32-CAM module and the TB6612FNG H-bridge module. The ESP32-CAM can supply Wi-Fi at 802.11b, G, or N. It's also capable of Bluetooth 4.2 with Bluetooth Low Energy, although we won't be using this feature in our design. This microcontroller can be clocked up to an incredible 160 MHz. The ESP32-CAM module brings 9 of the ESP32 GPIO ports out. It also has a built-in flash LED, and this is the LED we are using as a video light. The TB6612FNG H-bridge is a MOSFET device with a lot of superiority over the common L298N, and that's why I chose it for the design. This device can handle a motor voltage of 2.5 to 13.5 volts DC. It also is capable of using a logic voltage of 2.7 to 5.5 volts DC, allowing it to be used with both 3.3 and 5 volt logic. The TB6612FNG can handle 3.2 amperes per output as a peak. It can also handle a sustained 1.2 ampere output for each motor. The device requires no heatsink and has a built-in thermal shutdown. Now, I built my robot car upon a popular two-wheel robot car base. I'm sure you're familiar with these. These are available very inexpensively from a number of sources. There are also four-wheel versions of this base, and you can use this as well by tying the motors on each side in parallel. Just make certain to keep in mind the maximum current capabilities of the TB6612FNG when you're doing this. But the real fun would come from adapting an existing toy car or vehicle for your own purposes. After all, this is your robot car, so let's go ahead and build it. Now here's the robot car that I built, and as you can see, it's a pretty basic assembly. It's on one of these standard plexiglass bases that has the two motors on it and a caster at the back. Now I should mention I added another caster onto mine over here on the front, and the reason I did that is I found that my design was rather front heavy and kept lifting up. Now there are a number of other ways I could have resolved that, of course. One way would have been to move the batteries further back, or maybe move this caster a little forward, reverse the position of them. Another way would be to move this whole assembly more toward the center, but since I happen to have another caster, it was the easiest way to do it. Now as you can see, it's a pretty basic layout. I've got my power supply over here. These are the LiPo batteries, the 18650s. And at the bottom over here, we have a main board, and the LiPos connect to that. There's another connector on the board over here, and that goes down to the motors. This is the motor driver, and this is a voltage regulator that I'm using to create the 5 volts for the ESP32. Now the ESP32 itself, as you can see, is mounted on another board, and that board actually can unplug if you want to. And the board has a socket on it over here, and that socket is for an FTDI adapter. So you can plug in an FTDI adapter when you want to program it. Now when you want to program it, there are also two jumpers here. This one needs to be inserted in order to put it into program mode. That's the one that attaches GPIO 0 to ground. And this one, if it's inserted, it allows you to use this module standalone and use the power supply from the FTDI adapter. Otherwise, you leave this open so that the power supply on the FTDI and the power supply here don't conflict with each other. And if you had that open, you would just power this on when you were programming it, and of course you'd have it back in the socket over here. So I'll put that back in. Now I'm going to power this up for a second. And as you can see, I've got this really cool LED that's changing colors and flashing, and that's actually nothing that the microcontroller is responsible for. I'm just using these, and these are from Pimaroni. They're rainbow LEDs, and so you basically treat them like regular LEDs, and they do this color changing by themselves. And I just thought it looked pretty neat, but of course you could use a regular LED there. As you can see, the power switch and the antenna are all mounted on a separate board, and that's hooked up with spacers, and that lifts it up and also lets me run the antenna down to the ESP32-CAM, and we'll talk a little bit more about the antenna in a little bit. Now I'm going to turn it off again and turn it on one more time. Now look at the ESP32-CAM when I turn it on, please. Give it a second, and there, if you saw those flashes indicate that it has now set up a Wi-Fi access point and it's ready to go. So there you have it, a very compact assembly and a really neat little toy. Now, as I said earlier, this is a project that you can build your own way. You could certainly follow all the instructions that I'm going to present to you and come up with a robot car that looks just like mine, but you could also experiment with stuff that you already have. Perhaps you've already got another robot car base, or you've got a few motors and some wood and you want to build a robot car base. Maybe you've got a radio-controlled car that doesn't work anymore, or another model vehicle that you'd like to modify and turn into a remote ESP32-CAM car. You can do that, but there are a number of design considerations, however you build this, that you're going to have to follow. And that's what I want to go over right now, some of the main design considerations, starting with some considerations around the ESP32-CAM module itself. For only $9 US, the ESP32-CAM is an absolutely amazing module. However, in order to create an inexpensive module like this, some compromises had to be made. One of the most obvious compromises is the lack of GPIO pins. There are fewer GPIO pins on the ESP32-CAM module than a normal ESP32. This is because many of the internal GPIO pins are already in use for either the camera or the included micro SD card. In addition, many of the GPIO pins that are available have shared uses. For example, GPIO pin 0 is used to put the program mode on the ESP32-CAM. GPIO pins 3 and 1 are used for receive and transmit. Now, these pins can be used in your design, but it may compromise your ability to test your design if you make use of them. The ESP32-CAM also uses a number of shared resources in the form of internal registers and timers, and these can conflict with your program as well. Many of these resources are used by the camera. On the subject of the camera quality is an issue. The camera quality is reasonable. It is a 2.1 megapixel camera, but I have found that there is quite a variance in the quality of these cameras. If you're building this project, it might be a good idea to have a couple of ESP32-CAM modules and select the one with the best picture. Another issue with the camera is mounting the camera. The camera itself is mounted to the ESP32 with a very short cable. Now, there might be a method of extending the cable, but I'm not aware of it myself. So you basically have to manipulate the ESP32 module itself in order to position the camera. So this can be a little awkward in some designs. And a final consideration with the ESP32-CAM is the antenna. The ESP32-CAM module has a built-in antenna etched on the printed circuit board. However, for optimum performance, you will need to use an external antenna. There is a connector on the board for an external antenna. However, you will need to make a slight modification to your board in order to make use of this connector. I'll be describing that modification in a few moments. Now, another consideration that you're going to have when you're constructing your robot car is how are we going to power it? And there are a number of different choices that you can make, and I've got a few of them over here. Now, the method I employed was to use a couple of LiPo batteries. LiPos 18650s to be specific, give out 3.7 volts. So if I put two of them together, I get 7.4 volts. I've got a handy little holder over here that'll put them both together. And I'm using the 7.4 volts to drive my motors directly. Even though they are specified as being 6-volt motors, they don't seem to mind the extra voltage, but that's just me doing that. Hopefully that'll work for everyone. I'm also regulating that down to 5 volts to power the ESP32-CAM, and I'm doing that with this LM2596 based DC to DC converter. Now, you could use a number of different power modules, not this one specifically. This is an adjustable regulator, so once you hook it up, you have to adjust it to get a 5-volt output. It's not going to do it automatically, and that's a very important step if you're going that route. Another couple of ways you could do it, remember we have to give two voltages, a motor voltage and a 5 volts for the ESP32. Another way to do that would be to just use a 6-volt battery, which I've made over here with 4 AA cells in a holder, and this could power my motor. And then for the 5 volts, I've got over here a number of these USB power banks, and these things are great. Basically, they have one of these batteries inside them, and you charge them up with one port and you power with the other port. So you could actually have facilities for charging up your robot, or at least the 5-volt side of it. And that's kind of nice because I haven't made any provisions on my design to actually charge the batteries while they're in here. When they run low, I've got to remove them and put them in an external charger. So as you can see, you've got a lot of different options for powering up your robot car. Essentially, you need to get the 2 voltages, so be creative. Now, in order to use the external antenna with the ESP32-CAM board, you're going to need to make a slight modification to the board. And what you see over here is the bottom of the ESP32-CAM board, where you can see the antenna itself. Now, this is the built-in antenna that's etched onto the board, and there's also a connector over here for the external antenna. Now, in order to use that external antenna, which I would advise you do for better performance, you're going
going to have to make a slight change. Now if you look right beside it over here, you'll see a few solder pads, 3 of them. And these 2 pads over here have a small resistor that is inserted there, the surface mount resistor. And this is a 0 ohm resistor, which is another word for a jumper wire. And what you have to do is remove this resistor from this position and put it up in this position over here, pointing toward the connector, and that will send the antenna signals out the connector as opposed to the etched on antenna. Now since this is a 0 ohm resistor, you don't actually have to remove the resistor and insert it in this direction. You can also just remove the resistor and insert a jumper wire, and I've done that to another board. Let me show it to you. It's not the prettiest thing in the world, but it certainly serves the purpose. In this case, I have now removed my resistor, and you can see there's a little wire that's now pointing toward the antenna connector. And so now this board can be used with an external antenna. So if you want to do that, you're going to have to make the modification to your ESP32-CAM board.
Alright, we've got all of our components together and we've taken a look at a number of design considerations. The next step is to actually build our robot car. So let's get started with the wiring of the car. Now, I've divided this up into a couple of different sections in order to make it a little simpler for you to understand, and you can also get the wiring diagrams on the article that accompanies this video on the DronebotWorkshop.com website. The first section we are going to look at is the FTDI adapter. This is the adapter you need to use in order to get your program from your computer onto the ESP32-CAM module. It adapts the USB connector of your computer to signals that the CAM module can understand and use. Now, you don't need to have the ESP32 adapter mounted permanently to your robot car, and in my design I don't. I've simply provided a socket for the adapter and I can plug it in whenever I want to program the car, but this is really up to you. So let's go and take a look at the wiring of our FTDI adapter. Now, for our first hookup, we will of course require the ESP32-CAM module, and we'll also need an FTDI adapter. Now, you'll need to set your adapter for 3.3 volt logic, and you will likely find either a jumper or a solder pad on the device that will let you accomplish this. We'll begin by wiring the ESP32-CAM 3.3 volt input to the FTDI adapter VCC output through the PWR jumper. This is the jumper that we can use when we want to power the ESP32-CAM from the FTDI adapter and not from our internal power supply. We'll then connect the ESP32-CAM GPIO 3 to the FTDI adapter transmit or TX line. ESP32-CAM GPIO 1 will be connected to the FTDI adapter RX. The ESP32-CAM ground will be connected to the FTDI adapter ground. Now, GPIO 0 on the ESP32-CAM will be connected to one pin of the PGM jumper. The other side of the PGM jumper is connected to ground. This is the jumper that needs to be inserted when you are programming the ESP32-CAM. And this completes our wiring. Now, the next component that we need to hook up is the TB6612FNG H-bridge Motor Controller. Now, this is the device that, of course, will provide power to our 2 DC motors, and it needs to be hooked up to both the ESP32-CAM module and to the motors itself. I used a small connector to connect my motors to the circuit board that I was wiring this on. So let's go and take a look at the wiring of our motor controller. The motor control section of our wiring will involve both the ESP32-CAM module and the TB6612FNG H-bridge module. I'm also going to use a 4-pin terminal block to connect the motors. However, if you're using a solderless breadboard implementation of this, you won't require that. We'll begin by connecting the ESP32-CAM VCC to the motor controller VCC. We'll also connect the ESP32-CAM VCC to the TB6612FNG STBY, which is a standby input. This needs to be held high for the controller to work. The ESP32-CAM ground will be connected to the TB6612FNG ground. The 5-volt output from the ESP32-CAM power supply will be connected to the ESP32-CAM 5 volts. The ground from the power supply will be connected to an ESP32-CAM ground. The motor voltage positive output from our power supply will be connected to the TB6612FNG VM, or motor voltage input. The ground from the motor voltage power supply will be connected to one of the TB6612FNG grounds. ESP32-CAM GPIO pin 12 will be connected to the motor controller's PWM-A input. ESP32-CAM GPIO 13 will be connected to the TB6612FNG A input 2 or AIN2. The GPIO 2 will be connected to the motor controller's A input 1 or AIN1. GPIO 15 is connected to the motor controller's B in 1 or B input 1. ESP32-CAM GPIO pin 14 is connected to the TB6612FNG BIN2 or B input 2. We'll also make the same connection from GPIO pin 12 to the PWM-B input on the TB6612FNG. Finally, the motor outputs. The motor controller A01 will be connected to motor A's positive side. A02 will be connected to motor A's negative side. B02 will be connected to motor B's negative side, and B01 to the positive side of the B motors. And this completes the wiring of the motor control section. Now the final section that we're going to need to wire up for our robot is the power supply, and you could use a different power supply than the one that I'm using if you wish. The requirement is that you're going to have to come up with two different voltages, a voltage for the ESP32-CAM module and a voltage for your motors, and you don't want to use the same supply for both because the motors could induce electrical noise that would interfere with the ESP32-CAM module. Now the ESP32-CAM module is a 3.3 volt device, but it has both 3.3 and 5 volt power supply inputs because it has internal voltage regulators. And many people have found that it is more stable when you use the 5 volt input. So that's what we're going to be using to power our ESP32-CAM. As for the motor supply, well, that really depends upon the motors you're using, of course. The ones I'm using generally like about 6 volts, and I'm actually giving them a bit more than 6 volts, and they seem to be fine with that. So you'll have to adjust that to whatever your motors are. So the supply I've built basically uses a couple of 18650 batteries, which I'm using directly to power the motors, and it uses a small DC to DC converter to create the 5 volts that I need for my ESP32-CAM. So let's go and take a look at how I wired that up. The power supply I built used two 18650 LiPo batteries. I also used a DC to DC or buck converter. The one I used is based on the LM2596, and it's an adjustable converter. You can use another similar device if you wish. You'll need a power LED. I used a Pimerani COM0625 rainbow LED, but really any LED would suffice. It will require a single pole, single throw switch. This will be our power switch. We'll need a dropping resistor for the LED. I used 220 ohms, but any value in this range would work. I also used a 2-pin terminal to connect the power from my LiPo batteries to the power supply. Now, if you're using a solderless breadboard implementation, you probably won't require this. We'll begin by connecting the positive output of the 18650 battery pack to the terminal and then through to the SPST switch. The other side of the switch will be connected to V-in positive on the DC to DC converter. The negative side of the battery pack will be connected to the terminal and then through to the V-in negative side of the DC to DC converter. We'll take that positive V-in and run it to the positive motor output. The negative V-in will become the ground on our motor output, and this motor output should supply approximately 7.4 volts to run our motors. The V-out positive from the DC to DC converter will be connected to the positive ESP32-CAM power supply output. V-out negative will become the ground for the ESP32-CAM output. This will be a 5 volt output. The Vout positive will also be connected to one side of our dropping resistor, and we'll connect the other side of the dropping resistor of the anode of our LED. And finally, the Vout minus will be connected to the cathode of the LED. Now, before you install the ESP32 into its socket, it's very critical that you adjust your power supply to 5-volt output if you're using an adjustable regulator like the one I'm using. And this completes our power supply circuit. So now that we've got everything wired up, we just need to put it all together to build a robot car. So I'm going to show you how I took the individual components and put them onto my robot car base and assembled everything. Naturally, if you're building this car in a completely different configuration in one of your own model cars, you'll need to do things differently, but you can learn a few things from the design considerations and the methods I used of assembling my car to assemble your car. So let's go and do that right now. In order to show you how to assemble the robot car, I've taken mine apart so you can see how I put it together. Now, the whole thing is based, of course, on one of these little robot car bases, and I'm sure you've seen these things before. They're very inexpensive. They're about $15 or $20, and they include a couple of motors with them, and they also include this rear caster for balance. Now, as I said earlier, I added a second caster on the front. Now, as you can see, the motors are mounted. They just have a couple of wires soldered to them, of course, and I've tie wrapped them over here to keep them pretty. And I've got them passed up through a big hole that was already in the car base. Now, when you get one of these bases, you'll find that this piece of acrylic is actually covered in brown paper, and that serves two purposes. First, it protects the acrylic, so you remove it before you actually install everything, and it's nice and shiny when you do that. But another thing that brown paper is really good for is for getting the locations for any of the extra holes you're going to have to drill. Now, I had to drill some extra holes. I had to drill them for these mounting posts over here, which is for my main board. I also had to drill some holes to mount the battery holders. I think you can see that underneath over here. And I drilled some extra holes, of course, for my caster over here. And so I marked all of those off on the brown paper and then put them through the drill press, and then after that I took the paper off. So that makes it a lot easier. Now let's take a look at the boards that go onto this, and everything is really down to 3 basic boards. I'll just move this aside so you can see these. And I'll take this one off. Okay, this is the main board over here, and this main board is got the driver, the H-bridge controller, and it's got the voltage regulator, the DC to DC converter. I've got a couple of connectors. These are the connectors that are the output of this motor controller, and this is the input for the converter. This is a little connector that I run up to a 4-conductor cable, and that allows me to run to the top board, and that does the power switch and the LED. Now, the wiring on all of this is actually quite simple. When I wire up with perf board, I use 2 different types of wire, and you can also see that on the back of this board over here, the one that I've got for the ESP32-CAM. I use 30 gauge wire that's also called wire wrap wire for most of the data connections and that, because it's very small and very easy to work with, actually. And then I use a larger gauge. I use 22 gauge wire for anything that has to do with power or ground, and I've always done it that way. You'll notice also that if you can see that, I've used the 22 gauge wire as well for the connections out to the motor. So anything that needs to handle any current that isn't data, I use that for. Now, these spacers and all the hardware, this is 2.5 millimeter stuff, and these really long ones are actually, let me just unscrew them over here, is actually 2 spacers. I've just put them on top of each other, and spacers or standoffs, if you want to call them that. They allow me to elevate that second antenna board so that I can bring that up to a good height for the antenna. Now, the antenna board, as you can see, is also a very simple board. It's a very small one. It's got the power switch, it's got the LED in its dropping resistor, and a connector for the antenna, which of course runs to the back of the ESP32 board. Now, I've used a socket for the ESP32, and you're going to want to use that as well, because you want to be able to get access to the switch over here, the reset switch on the ESP32. I've also used a socket for the motor controller. Now, you don't need to do that. In a way, it might help because it adds a little air circulation under it, but really this never gets that warm. I just thought it was a bit easier, but you could also wire the wires directly and eliminate the socket if you wanted to. Excuse me. And so that's how I wired up my robot car using perf board on 3 different boards. And if you want to go ahead and do the same thing, that'd be great, but you can also, of course, come up with your own mounting style. Well, now that we've got everything wired up and everything all hooked up on our car, it is time to write some code so we can actually make it work. Now, the code that I'll be using is fairly complex when you look at it. It's actually divided into more than one file, and it contains a lot of code that was taken directly from Expressive's example for using the ESP32-CAM module and making a video stream, so I certainly can't take credit for the majority of the code you're about to see. What I'm going to do is show you the sections of the code that you can modify to change the things that you might want to modify. For example, you may want to modify the look and feel of the interface. I designed a fairly ugly interface for this car, and I'm sure you can do much better if you've got some experience with cascading style sheets. So I'll show you the sections that you can modify for that. I'll also show you the sections you can modify if you want to add some extra features to the car, like add an extra I/O device or something, and I'll point you out to the areas that you can modify in the code for that. So let's go and take a look at the code and at the things we can modify to customize the car for our own purposes. Now here's the code that we're going to be using for our ESP32-CAM robot car, and it consists of 2 different files. The first one is ESP32-CAM-robot.ino, and this is the main file, and in this file there isn't very much that you are going to want to modify, except perhaps at the beginning over here. And these are the credentials for the access point. Remember, we are setting up our ESP32-CAM robot car as a Wi-Fi access point. So as a result, the access point will require both an SSID and a password because it's a secure access point. Now, we've made the SSID ESP32-CAM robot, but you could change this if you wanted to. You could also change the password, but otherwise it's been set to 12345678890. And you should remember that because you're going to need it to connect to this network. Otherwise, there is not very much that you can modify in this file. It is basically just a copy of a lot of the stuff from the Expressive example for the ESP32-CAM. In the loop over here, we're comparing a value called previous time passed to us from the other file to the current time to make the robot move a specific amount of time, and we will see that in the second file over here. Now the second file, app_httpd.cpp, is the one that you will want to modify if you want to change the look of the interface or if you want to add additional components to this. For example, when I was designing this, I actually had a couple of servo motors to pan and tilt the ESP32, but I found it too awkward to do that, so I removed them. But you could put something back in here if you want, and this is where you're going to do it. Now again, this is a huge file, and you'll notice I've enabled the line numbers so that I can conveniently jump to a line. So let's first of all look at the HTML, which I believe is around line number 374. So let's go there. And here we go. And this is the HTML that is going to display the actual buttons. And as you can see, it's a very basic table-based design. I'm sure those of you who are much more proficient at HTML could come up with something much better using cascading style sheets. But for this simple application, this will suffice. Now, all of these are buttons at the top over here, and at the bottom here are sliders. And on the buttons, for example, you'll have a couple of things that you could modify. For example, the button class. The button class is what determines what the button looks like. And that refers to an entry in the cascading style sheet, which I'll be showing you in a moment. And then the button ID, which is a unique ID for the button itself. The button ID occurs in the on-click event as well over here. on the on-click event of the button, we pass back a couple of variables. And in this particular one, we pass back two variables, car and val equals 5. The one below it is for the light, and it's flash and val equals 1, etc. These values are passed back every time we press the button, and this is what lets us determine which button has been pressed. And if we want to see that, we'll bump up over here again. Let's go to line 307. Now up over here you can see we have a bunch of if-else statements, and they are looking for those values that are passed back. So for example, for the backward one, if the value is 5, and at the top over here we said the variable is car, and the value is 5, we call a function called robot back. And those functions are actually located down near the bottom of the code, and that's around line 489 according to my notes. So let's go there. And as you can see, we have a number of motor control functions. Here's a stop function, here's a forward, here's the backward function. And so these backward function, this basically goes and talks to the TB6612FNG Motor Controller. It sets it up so that the motor is spinning in the correct direction, and that's what it's doing over here. And then it simply sets a move interval, and it sets a value of previous time to the current value in milliseconds. And that, of course, is what we saw in the loop earlier. That tells it what to do. So if you hit the back button, the robot is going to move backward for an interval of 250 milliseconds. Now, if you want it to be a shorter or longer interval, and you'll notice left and right have different ones for 100 milliseconds, you could go and change that in this part of the code over here. Now, if you want to change how everything looks, what you really need to do is go and look at the style sheet. However, the style sheet is a bit of a problem. Let's go and take a look at it. I have it listed here as being on line 355. And there it is. And here's your style sheet. And as you can see, it's a little difficult to do anything with this style sheet, and that is because this style sheet has been minified. Minification is the process of taking out all of the spaces and carriage returns and all of the characters that your web browser doesn't need to see, but humans like to see in order to make code readable. And it's a method of sending less bytes of data to the web so that everything works a bit faster. And you can minify and unminify quite easily with some utilities that are available on the internet. For example, here's one called unminify. If we pasted that entire string into here, we would get the unminified version of it. And if we wanted to minify it again, we can go to a minifier, and we could put our code into here and it would give us a minified version of it. And there are dozens of these up on the internet. I'll leave a few links in the article accompanying this video. Now, in order to save some time, I've also given you another file, and it's a version of the same file with the cascading style sheets unminified, and that's over here. I've got it open in Genie right now. I've got it open to a specific point, actually, down around line 484, because this is where all the buttons are defined. And so, as you can see, we've got a number of different buttons. Button 2, button 3. The basic button is up over here. Then button 2, 3, 4, 5, 6. You could add additional ones, change their color, change their width, etc., and add those parameters and call them from your code. So if you wanted to add extra buttons, this is what you would do. So these are a few simple modifications you could make to this code in order to make it your own unique code for your robot. And so all you'll need to do after you do that is to load this up to the ESP32-CAM through the FTDI adapter. Now, I'm going to assume that you know how to do that, but if you do not know how to do that, I've created several articles and videos that will show you exactly how to do it, and you'll find links to those as well in the article that accompanies this video on the DronebotWorkshop.com website. So, assuming you know how to upload the code, let's upload it to our robot and give it a test. Okay, we've got everything assembled and hooked up. We've loaded up the code. Really, the only thing left to do is to test out our car and see how it works. So let's go give our robot car a test drive. Okay, let's give this a test. I'm going to flip the power switch on it. And let's see if we have a Wi-Fi network. I'm going to go up over here, select my network, and there it is, ESP32-CAM robot. And we'll connect to that, and of course we need to authenticate because this is a secure Wi-Fi network. And if you remember our password, 123456780, and I believe we're connected right now. Does this confirm that? Yes, we're connected to there. And so we need to go to an IP address of 192.168.4.1. And there we are, and there's our interface. And so we can start our interface right now. And as you can see, we've got a camera, and here's a look at some of the recording equipment and some of my workbench and everything as I'm spinning this around. Now let's actually see. I'm just going to lift this up because I don't really want it to go anywhere. Let's go forward. We seem to have motors moving. Reverse, left, and the motors move in opposite directions. Right, they move in the opposite ones. I should be able to control the motor speed. Let's set it a little lower. And a little faster. Go all the way to the top. See how fast we can go. Seems pretty fast. Now the video quality can be adjusted over here. As you can see on this end, the quality of the video has really suffered. But of course, it's taking less bits to send it. Over here, it's nice and smooth. We can also adjust the size of our video display if we want to. So that does seem to all work right now. Oh, and one more thing I guess we can check over here is the lights. Here's the light, and we can turn that light on, and we can turn it off. And so our remote seems to work, and our car seems to work. So I think the next thing to do is to give it a test drive. Well, I've got to admit this was really one of the more fun projects that I've worked on in a long time, and I was quite amused about the fact that I could drive this on the second floor of my home and control it from down here in the basement. You do get a very good range with this antenna over here. I think this would be an excellent project for those of you who are trying to instruct or get someone interested in electronics, let's say your children or your grandchildren, or if you're an instructor teaching electronics, because it sort of encompasses a bit of everything. You've got some coding in here, you've got wiring in here, you've got theory that you need to understand. If you choose to assemble it the way that I did, you're also going to be doing a bit of soldering. So really you get to exercise just about everything, and at the end of the day you come up with a fairly unique product that's a lot of fun to demonstrate. Now if you want some more information about this car, if you need to get the schematic diagrams, or of course if you want to get the code, you know where to find that. It's on the dronebotworkshop.com website in the article that accompanies this video, and there's a link below the video to that article. While you're on the website, you might want to consider signing up for my newsletter. Now, this is not a spam or a sales letter in any way. It is just my way of keeping in touch with you to let you know what's going on in the workshop. And, of course, on the subject of subscribing, if you haven't subscribed to the YouTube channel yet, please do me the honor of doing that. All you need to do is click on the subscribe button, and when you do, you can also click the little bell notification. And as long as you've got your notifications enabled in YouTube, you will get a notification every time I make a new video. And if you want to discuss this robot car or anything electronic, well, the best place for that is the DroneBot Workshop forums, where you'll find a number of like-minded individuals who really like to talk about electronics and can help you out with any of the issues that you are having. You'll find a link to the forum right below this video, and you'll also find a link to a section in the forum exclusively dedicated to this project. So until we get together the next time, please take care of each other, please stay very safe, and I will see you again very soon here in the DroneBot Workshop. Goodbye for now.